Hello, good afternoon, evening, or morning to wherever you're tuning in from. Welcome to today's stream. I'm Ryan, and we're going to be learning about oscillations today. And hopefully, we're going to have time to get to doing some wiggles. um, Before I do that, I had a few things I really wanted to share on the topic of wiggling and oscillations and things that are related to what we're covering today. I wanted to share two things. One is there is a children's group based out of Australia that's called the Wiggles. Now, I have a little bit of Australian heritage, and so I like to try to bring that in whenever I can. And so I think today, since we're learning about oscillations, I figured this would be a really funny thing to I guess, like bring in. It's kind of giving. Let's see. I don't know what the American equivalent of the Wiggles is, and I don't know what the other international equivalents of the Wiggles are. But just know it's a children's band. So I yeah, I'm reminded of that. I don't know how much actual wiggling they do. Um, Maybe the same amount of actual wiggling we'll be doing today. While I keep yapping, actually, I want to make sure I give you all a opportunity to check in to the event page right over here. It is also available at the QR code right above me. But if you're only on one device, that is no problem at all. I am going to go ahead and share the link in chat. Um, and the way I like to run all of my workshop resources is I just leave everything available in the Discord announcement. So if you want to uh, follow along later down the line, you can always take a peek at that and just find what we're looking at. In the meanwhile, I'm going to keep myself entertained by going to this wonderful website over here, spinningrat.online. Any guesses to what this is going to be? Anyway, I'm going to get this thing started just because it's too fun to not. So yeah, it is indeed what it sounds like. It is a spinning rat online, very low resolution rat. The more people that are watching this website, the faster the rats actually go, which is probably one of my favorite things about this website. There's many other reasons to love it, but yeah. Anyway, let's get this thing started. So the way that these workshops usually go, this is part of a ongoing series um, that is called The Nature of Code. Basically, the reason why it's called that is because one, we're following a book that's literally called The Nature of Code. It's written by a awesome programming artist. His name is Daniel Shiffman. He's also a professor at NYU, and he's a very cool guy. Haven't had the chance to meet him yet, but we're doing the good deed by sharing his book, which is freely available online, which is freaking awesome. So we are currently on chapter 3, but if you are a programmer and have programs for a while, you may recognize that we use zero-based indexing. So technically speaking, this is actually the 4th chapter in the series. We had randomness, vectors, forces, and oscillation. Now, typically, um, what I've seen is that these workshops take usually about 2 Global Hack Week sessions because of the speed that I program at. Unfortunately, this GHW I only have time to run one workshop stream. So we're going to see how far we can get with oscillations, and then we will pick up wherever we started. Well, we'll probably pick up on the next chapter by the next GHW. But yeah, if you want to, or if you haven't been to any of these streams before, that is totally fine. I like to try to run these streams so that you can drop in at any time, and you'll still have a pretty good understanding of what's going on. So if all of this stuff is pretty confusing to you, like what is this editor that I'm using, I will walk through that very shortly. Okay, so let's get started. P5, the name P5 is a JavaScript animation library, And so basically that means that we can use all of our JavaScript functions that we're familiar with and use that to use that with this library to animate things, which is pretty fantastic. This book focuses a lot on trying to simulate natural systems being physics and even biological natural systems to, I guess, like replicating and emulating or simulating natural behaviors. So usually there's a lot going on over here when we have an example pulled up, but this is what a very basic example looks like within P5. P5 is part of it's managed by an organization or a foundation that's called the Processing Foundation. Very cool foundation. They also do other forms, or like they also have other libraries, which is pretty awesome. Let's see if we can find them right now. Yeah, they have the original project started in Java. We're looking at the JavaScript one, but they also have a Python and an Android app system. Okay, so now let's actually give you all a tour of what the P5 space looks like. So as I mentioned before, it lives in JavaScript. Uh, you can see here that the title of this file is called sketch.js. And to illustrate this point further, if you've done any sort of web development, you'll know that in order to have your JavaScript display anything in the browser, you will need an HTML file. And so over here, if we pop this tab open, we can see that we indeed have an HTML file. So an HTML file is just a file that contains some information on how the structure, I guess the content and structure of what your website should look like. Now, it is a little bit meta in the sense that we have a HTML tag inside of our website, which is a little bit silly if you think about it. But we don't need to think too hard about that. Let's actually take a quick look inside here to make sure that there's nothing too crazy going on. So over here, we just have really two main things within HTML. HTML is a hierarchical structure, which means that very generally, there's things inside of other things. I see a question. Do these concepts apply to other languages as well? I don't do web development, but this is something very interesting and I kind of want to see it, but you've never used JavaScript before. That is a fantastic question. I would say yes. While this textbook in particular is very focused on giving all of the examples within P5, the reason why P5 has been chosen is because it's a very accessible thing and you don't need to download anything to get started by using it. However, if you are more familiar with another language, like Python or Java, you could totally use the processing library for both of those languages if you would prefer to do that instead. But the concepts over here are fairly transferable. You would just need to figure out how the language that you're working with represents the equivalent of most of these. Now, a lot of these functions that we'll be looking at, they aren't too crazy. They do a little bit of math behind the scenes, but that's not something that is, I guess, like particularly fancy or unique to most languages. The main thing is P5 is just a convenient drawing library, like animation library for that. I think like when I'm done going through this textbook, I would like to revisit everything and view it from a game development lens. So I'll probably be taking the game engine Godot and trying to replicate, I guess, like a lot of the things that we'll be learning in this book. Anyway, that is a fantastic question. I do hope that you'll give it a shot in P5, just because of the ease of, I guess, like entry into this. Another question, is there a tutorial repo or page we can follow to stay up to date with the code? Fantastic question. Yes, well, kind of. Basically, after a stream, I will be sharing, I'll send a reply to the announcement for this stream with all of the code links that we used on stream. So one of the reasons why I really love P5 is um, how easy it is to share code. So basically, if I take a look in here, we can try to understand this URL right here. First off, we start off with the base URL, which is editor.p5.org. And then we have my username on here, totally not Frito-Lay's. Then we have sketches. And then we have this thing right over here. So if you would like, I could share this right now, and you'll be able to see the exact same thing that I'm seeing. Well, it may be a little out of sync because it doesn't, what's it called? It doesn't have live updates. That is, if I change something on this page, in order to see it somewhere else, then I would need to reload that page. So for example, if I run this script, actually, let's start with a simpler script. Let's start with this. So all this is doing right now is it is simply drawing a blank square, basically. That's a gray square. Okay, so now if I copy this over here, oh, this isn't, I'm not actually logged in, so I'm gonna go ahead and log in. Thankfully, it has login with GitHub, which is really convenient for me. So if I run this again, we've got Scrawny Giraffe over here, and now if I look over here, it still doesn't have, okay, so now I've saved it. So after I've saved it, then it's generated a link. So now I can pop over here, put this link over here. And now let's go ahead and change this color. Instead of 220 on the grayscale, let's actually add in a couple more values. Let's add in 100 and maybe 200. This thing uses red, green, blue values, RGB, to create colors. And so now we've got a lovely pink over here. And if we look over here and run this, we can see that it's still gray. So if you're following along, I would prefer, or this is the reason why I generally like to share the links post-stream as a reply to my Discord so that we don't have to worry about being out of sync. The other thing to keep in mind is that if you are not on the same account, then oh, what was I going to say? Oh, when you make changes, the changes won't save unless you were logged in, which kind of makes sense, I think. But yeah, if I wanted to demonstrate how this would stay in sync, all I have to do is just reload this and then run it again, and we can see that we're now in sync. Okay, so that's a little bit about sharing the links for P5. I want to also quickly show, I guess, like in greater detail, what's going on in the HTML file so that we don't have to revisit it and be confused or like try to visit this file to try to as part of our debugging process. So yeah, basically within the header tag, we've got two elements, and within these tags or elements, they are scripts. These scripts attach to the library themselves. So this is where the library is defined for P5. And then we've got another one, it looks like for the sounds library. If there are any add-ons or extensions to the library, all you would need to do is you would need to find the link to wherever it is hosted. In this case, it is being hosted on this CDN, aka, or like in other words, a content delivery network. And yeah, you would just add in a script right there. Boo, 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 boo. Okay. So then we also have a link to a style sheet, which is just a CSS thing. This basically is a very simple CSS reset. It removes some line, I guess like some padding, so that whenever we draw our canvas, which is this element right here, it's going to be drawn to the top left of the starting part of the screen. Okay, and so Something that may be interesting is that all of the content within sketch.js loads inside of a canvas, but if you look at this HTML document right now, there's actually no canvas here, but if we were to actually inspect this page and run this, we would actually be able to see that there is a canvas here within the main tag. Actually, we can see all of the HTML that we were just looking at right over here. It looks like there's a little bit of extra things that show up. But overall, this is pretty much the same HTML that we were looking at earlier, which is pretty rad. So in other words, if you wanted to, you could technically take out the P5 library and put it into your own code editor instead of running it within the browser editor instead. Something else I want to, I guess, like highlight is that the way that websites work when they load JavaScript is they kind of load things from the HTML documents from the top going down. And so it's kind of like if we had kept everything in a single page or like in a single JavaScript file or like script file like Python or in Java. If we just have everything loaded, they all load from the top going down uh, with some exceptions, but generally speaking, that's the way it works. And so the idea here is that these libraries are called ahead of time so that when we get to the actual sketch function, we can use all of the functions within that library without having to worry about it. So you can think of it as like one giant JavaScript script. We're just loading in different pages, I guess like sooner, different files sooner. Anyway, if that doesn't make sense, please let me know and I can try to find an alternative explanation for that. But let's see. Is there anything else to highlight? I think that's pretty much it for this. So I'm going to go ahead and close this page. We're going to go back to looking at this example. This is the first example within the textbook. Now, since I do believe that you are all able to, maybe this is a crazy assumption, but the way I've been running these workshops is instead of reading along the entire textbook, because it's a lot of words, I will generally leave the reading to the audience, and we're going to basically use this stream as an excuse to get through all of the examples and exercises within this textbook. Unfortunately, this isn't one of the exercises within this chapter, but I do think it is a great kind of guiding artifact of what you can do with oscillations. And hopefully, depending on how far we get in the chapter, we will be able to create something similar to this. Yeah. Well, I think actually they might have just straight up just done a sine wave with a little bit of an offset with different colors to create this beautiful curved 3D-ish effect. Anyway, as we can see, our baton over here is in Spain without the A. In other words, spin. If that joke fell over the head, it's Spain minus A is equal to spin. Anyway, so I'm going to go ahead and skip over to the exercise. The main thing that this part of the chapter is part of the chapter is talking about is we're going to be introducing the rotation function. And so let's actually take a moment to break this down. Very generally, every P5 script starts with two functions. There is a setup function and a draw function. If you're familiar with hardware programming, like Arduinos, then this pattern may look familiar to you. Instead, in Arduino, we would have init and loop, but here we have setup and draw. Setup runs once at the very beginning, and draw runs every frame. after the setup. And then so what's going on over here is we're initializing first a few variables, global variables. We've got angle, angle velocity, and angle acceleration. And then we've got setup, which just draws the thing that we're sitting on. And then we've got draw itself, which, yeah, does a few things. Now, since I like to run this with side by side with the textbook, I'm going to go ahead and shrink the canvas down to be smaller. I think this looks fine. So we're going to go ahead and roll with that. Okay, now let's actually get into the draw function. So we've got a few things going on over here. The very first thing that's happening is we're running a translation, and then we rotate the object. Actually, no, before that, we're actually even drawing the backgrounds before we do anything else. And then we're defining what the pen is. I guess like the pen being the thing that draws the outline of what it is that we're looking at. So in this example, we've got a barbell, which can be drawn with a line and with two circles on either end. And then we've got a color of 127, which should be a nice gray. And then we're then defining the actual barbell itself, and then applying a velocity to it to change it based off of the angle. Now, I'm going to do a few things here. We're going to go ahead and hide some of these lines just to demonstrate what it is that they do. So the translation thing is basically just moving the base of our coordinate system to be in the middle of the screen. And the reason why is because, well, let's actually just confirm that by commenting that out. And we can see that now it's been moved to the top left corner. So within P5, along with most other animation libraries, the coordinate system is based in the top left corner. Now, there's a reason for this, and I'm going to need to refer to this whiteboard that I've set up in the past. So for some reason, the way that we learn about the coordinate system in school is when x gets bigger, it moves to the right. And when x gets smaller, it moves to the left. And then the same is true for y, but for going up and down. Now, this kind of makes sense because I guess when we take this example into the real world, we can imagine kicking like a couple of school kids maybe, kicking a ball, and we might want to chart the ball, I guess like where y is the distance that the ball has traveled from the ground into the air. However, for websites, we don't do that. We instead have the y flipped. So as y gets bigger, it is going down. Or I guess when y goes down, it's getting bigger. The reason for that is because when we are, I guess like, there's the idea of the ground truth, I guess, which is where we start from. So I guess in real life, we generally start, at least from the context of Earth, we start where we're all sitting on the floor, I guess like the grounds, basically. And so when we're building, we tend to build upwards. However, for websites, we actually generally start at the top and then we build downwards. That's the reason why when, for example, we're looking at like, let's take like Google Docs or like any sort of text editor. They generally start from the top and then they go down. And so if I were to continue spamming lorem ipsum, we'll see that this goes down. And so now the more convenient way to describe how far something is, or I guess the coordinate for which lorem ipsum we're looking at, we would actually look from the top going down. So that's the reason why the coordinate system, I guess, like gets bigger. That's the reason why y is flips, I guess. It's the best way to describe that. Okay. So now I'm going to go ahead and leave the translation back in there, and then rotate. I believe rotate actually rotates the entire coordinate system. We can confirm that by looking at the library. So I'm going to go ahead and pop over to the documentation for the library, which is available at p5.org/reference. Let me actually share that in the chat. Okay, so I've gone ahead and looked up rotates. So yeah, from the description, it rotates the entire coordinate system. There's rotate X, Y, and Z, but that's not very relevant. This is for more 3D things. We're not doing 3D things. We're going to stay in 2 dimensions because the math is a lot easier. Okay, so now we know that we're actually rotating the entire coordinate system. So I guess if we were to draw in like a box over here, let's just do like a rectangle at 0, 0, and then let's give it a side dimension of 25. This should just spawn in the middle. Oh, this is before the rotation, so let's actually, or before the translation. So if we pop this over here, we can see that the rectangle sits still. Honestly, I thought this this rotation thing affected everything, but I guess it only happens, I guess, like to anything after that. So I guess, yeah, we could add in the rectangle right there. I wonder if we could reset the rotation over here and if this would stay still. Nope. So I'm guessing we would have to actually do the angle in the opposite direction. Yeah, we would have to counter rotate in order to get anything after the rotation to, or after the first rotate thing to not rotate. But I guess if we wanted to rotate in the opposite direction, we could do something like that, which is kind of funny, honestly. Okay, I'm just gonna leave that there for now because I think that's very handy to know. All right, so over here we've got the angular velocity and angular acceleration things going on. That's not super relevant right now. What I want to do is I want to scroll down over here till we get to the first exercise, because I know this example is going to be relevant. I didn't write this example, by the way. I just ripped it straight from the textbook, and then we'll be riffing off of it. Riffing as in modding it to the exercise. Okay, so this over here is just explaining the difference between radians and degrees. Radians just makes the math simpler for a lot of the translations. And I think what's happening over here is we're also saying that the rotation over here actually, let's see, uses radians. Yes, P5 measures angles in radians. So that's something to keep in mind. So if our math is doing something funky, it's probably because we need to convert from degrees to radians or something of the sort. Okay, so here's the exercise that I've taken. We've got the translation and the rotation. We've got angular motion, which just takes a lot of the two-dimensional motion that we had earlier and makes it spin. Okay, so let's see. Wait, why do we have 2 examples? Oh, okay. So I guess technically speaking, we skipped the first exercise because we didn't draw our this thing from hand. But I think we've already spoiled ourselves with what the answer is there, so we're going to keep on going. We've got the example. This is the example that I actually stole earlier that adds in the acceleration. So we're going to scroll down here to the first exercise. Actually, what I need is I need to grab some water. Okay, I'm going to take a moment. All right. So what it is we're going to be doing is we're going to add some sort of interaction. We can add any kind of interaction that we want as long as we are modifying the mouse acceleration. So this is a two-part exercise. We can also introduce the idea of drag, where it eventually decreases the angular velocity so that I guess it's a subtractive acceleration. I'm just going to say that. And so I guess we can kind of think of this as, what's it called? The wind, you know, the weather instrument that measures the wind speed? Wind speed instrument. The anemometer, I want to say is called. So that's what it is, I believe we were making right here. I guess if we want to, we could actually doll this up a little bit to make it look more like a anemometer on a building. So maybe that's what we'll actually use this rectangle for. We would want to make this a little bit bigger. And we would probably also want to make it so that it is, instead of width divided by 2, we'll do, let's, we're going to call this building size is equal to 200, and then we'll do everything as a ratio of that. Building size divided by 2 on the x, and then we'll also want it on the y, and then we will do building size, and that should build us, oops. So we actually want to subtract that and subtract that. And okay, technically speaking, we will actually want to put this before any of the rotation. So let's go ahead and do that. And I want to actually make this a different color. Forgive me for thinking about aesthetics first. So we're going to run a fill. We're going to make this, instead of 120, let's make this a lighter color. Think of it like a Arctic research station. Oh, I guess that made it darker. Whoops. Let's make this a little bit lighter. There we go. Okay, so if we want to, we can theme that to be more interesting later. I'm going to go ahead and actually take this out and put it into a function that I'm going to call draw building. Oops. Okay. There we go. Okay, so now we've got our draw building. I'm going to also extract this out into a draw anemometer function. Draw anemometer. And I'm going to go ahead and remove that. Okay, so now if we run this again, it should continue working, and it seems like it's working all right. Okay, so let's see if we can make this any easier to read. Let's see. I don't know about you all, but I've found recently that having more comments in my code makes it actually harder to understand what's going on, because I feel like there's just a lot of fluff between the actually important information. Sometimes the comments are very helpful, but like in this case, we know that this is talking about angle, acceleration, and velocity because it's got a good variable name. Okay, so I think this is a pretty good start. Let's actually do the thing that it's asked us to do. So the main thing we need to adjust is the acceleration. So we know that we need to do something to the acceleration before it gets added right here. So let's go ahead and declare a new function. We're going to call this mouse acceleration. I love that we're learning about JavaScript-based art. Love it, and the simple explanations. I'm really glad you're enjoying this. I've been enjoying it a lot too. So let's continue learning together. Okay, so actually, before I say that, okay, never mind. Sorry, I just had a thought about something else. I'm technically running another workshop on P5 later this weekend, but I don't believe it's an open event. Otherwise, I would share it with you all. But yeah, you'll know every GHW I'm going to be trying to stream. I think next GHW I'm actually not going to be able to stream because I'll be coming back from a hackathon that weekend, and I need some time to recover before I go back to school. So unfortunately, next month I will not be streaming, but the following month I'll be streaming more GHW things. And you certainly don't have to wait for me in order to continue going through the rest of this book. Anyway, all right, mouse acceleration. So we know we need to adjust the angle acceleration in some way. That means we're going to be touching acceleration. We can go ahead and assume we're going to return acceleration. Okay, so then the next thing we want to do is we need to define how our mouse will actually affect the animator over here. Right now, this thing is going really, really fast. Maybe we should put in a max velocity on this thing. Let's actually go ahead and do that. Const max angle. We're just going to say max velocity, since this thing isn't actually moving from left to right. Let's put this at maybe 100. Okay, so if angle is greater than max velocity, I don't know why this bracket ended up so far out of place. Okay, if the angle is greater than max velocity, then we will not adjust the angle. So then we actually want to flip this. If it is less than the max velocity, we're going to add in the angle velocity. Otherwise, we're just going to leave it as is. I guess something to keep in mind here is that if we're adding in deceleration, we actually want to make sure we consider the, I guess, like directionality of the velocity, because we could be adjusting the velocity to go in the opposite direction. So I'm going to go ahead and consider that as well. Max velocity. I guess the thing that we could do is we could do math.absolute on the angle. That way we're checking to see if the angle is ever, I guess, bigger than the actual velocity. I guess this is, in this case, we're actually doing max speed. So I'm going to go ahead and rename that to be more specific. As a reminder, the difference between speed and velocity is that velocity has direction, whereas speed is always a magnitude, which basically means that's just how fast we're moving, not necessarily how fast we're moving in what direction. Okay, and I'm not sure if I got that right. I'm pretty sure, actually, that we have, yeah, there is actually a built-in function for this. I think the function I was using instead is the JavaScript math.absolute function. Technically speaking, this should also work if we wanted to. Now, JavaScript is kind of a very funky language. I think my professors, whenever They've talked about web developments. They always talk about how JavaScript was written in 7 days and it wasn't intended to become the gold standard for web development. Um, so there's a lot of really weird quirks around JavaScript. um, One of the nice things, though, is that a lot of libraries are just kind of already imported, so to speak. Like the math library, we don't have to manually import that. We just have access to that immediately. I'm pretty sure this thing under the hood, like how the P5 library defines the absolute function, it literally just straight up calls the math.absolute function in JavaScript. So if we wanted to, we could have done that. I'm going to be using the P5 one just for the sake of keeping things consistent. Okay, so as we continue coding, we should see this thing stop accelerating at a certain point. Maybe as that happens, we can draw the building a different color once it's reached max velocity. So let's see. Oh, or it'll just stop. Oh, that's because we put the wrong thing in here. We should have put the acceleration instead of the angle velocity. Okay, so we should see this thing stop accelerating at some point. Anyway, yeah. I don't want to get too carried away with this, so okay, I don't actually remember what it is we were doing. That's right, we were adding in acceleration. So the way I want to do this behavior is I want to make it so that depending on how far the mouse is to the left or to the right, that's how much our acceleration will change. So I'm actually going to bump this up to maybe 500 so that our changes can be more dramatic. Because right now the acceleration is changing by a little itty bitty amount. I think it would be cool if we could adjust this by a bigger amount. Okay, so I'm actually going to start by just returning the angle acceleration and then tossing this function in right here. So then that should continue. And so if we wanted to, we could actually set the angle acceleration to be much, much higher. We'll make it, well, much, much higher. I'm going to make it 10 times stronger. And so we can see that it actually speeds up quite a bit. So I think this is a good max acceleration for our project. And let's see. I'm going to use okay, well, first off, let's capture how far the mouse is from the center of the screen. And the way that we can do that is I'm going to go ahead and put this into a variable or a constant. Let's put this into a variable for now. And then we're going to call this variable distance from center. And then this will just be the, well, I guess the coordinates would be 0, 0 at this stage. So then we're just going to actually just take this as 0 minus, or okay, we don't have to worry about that, the 0 then. It's just going to be minus mouse x. Maybe we'll just call this distance x. Okay, so then this will take in, okay, I'm going to add in the 0 here, just so that we remember that this is the distance from the middle of the screen. So if the mouse is to the right of the screen, that is going to mean that our acceleration should be negative. We actually want that to be the opposite. So let's actually do, let's see, plus mouse x, the distance from the middle. I think, let's see, the way I was thinking about this math beforehand was based off of coordinate system that would be to the, I guess like to the right. Oh my gosh. Is based off of a coordinate system where we didn't do the translation. Okay, let's just do this for now. This is the distance from the middle. I'm actually going to wrap that into another number. We're going to call this center x is equal to 0. Just so that we remember that this is actually considering our the middle. Okay, since this is just a simple math function, I'm going to actually put this into a constant. And let's go ahead and log where our mouse is, distance x. Okay, so let's run this. So if we put it to the right, it is at 200. If we put it to the left, it's at 70. Okay, so this means that the translation isn't actually in effect here. So that means we'll have to actually consider the coordinates right over here. So I'm going to go ahead and do that. This should just be width divided by 2. Okay, so now we've got 300 versus 170. I think I did that wrong. Okay. Oh, that's because it's being added. So let's actually subtract this. So now if we're to the right, it's negative, and if we're to the left, it's positive. We actually want that flipped. So I guess what we can do is we can just subtract the center x from the mouse. So now if we're to the left, it's negative, and if we're to the right, it's positive. Okay, so that means if we were to add in the acceleration, I guess like, so yeah, if we go left, then that means it should start spinning. Oh my gosh, I forgot that my camera is mirrored. It should start spinning counterclockwise, anti-clockwise, versus where it's currently spinning, which is clockwise. Well, actually, wait, I don't remember. Yeah, it's currently spinning clockwise. So we want to make it so that as long as it's positive, it's spinning clockwise. However, distance x is in the magnitude of whole digits, which is a problem since we need to be working at a scale of much smaller than that. So there's this function that's called map, and that basically is going to adjust the scaling of how far we're looking. And I think it makes a lot more sense if we actually put it to use as opposed to me trying to explain it. So I'm going to go ahead and handle that right now. So we're going to do map x for this. I'm not really in love with my variable naming right here, but that's okay. I don't need to be. I just need to make it work. Okay, so the way that the map function works is the very first value we take in is going to be the value that, I guess, the input value. So in this case, it's going to be angle acceleration. No, it's going to be distance x. The next value it's going to take in, I believe, is the current distance, or the current variable's max or minimum then maximum value. So in this case, the minimum and maximum value should be whatever the width is divided by 2. And the screen is currently 240 by 240. So that means that the maximum it can be is 120 and negative 120. So I'm going to start off with negative 120 and 20 and 120. And then the next thing that we're going to have is we're going to have the new targeted minimum and maximum value. And so in this case, the minimum value we want it to be is 0.001, negative, and then maximum of 0.001. Now, to make sure we don't actually forget what these numbers are, I'm actually going to go ahead and replace these with some more constants. One of the habits I picked up in college, as far as variable naming goes, is we want to avoid magic numbers as much as we can. So we're going to avoid that by describing what these numbers are. And so in this case, negative 120 is going to be our distance x min, just negative 120, distance x max, which is positive 120. Now I know this is a bit verbose, but this is very handy for when we are, I guess, like programming much bigger things. So I'm going to go ahead and break this into different lines, just so it's easier to read. And then we're going to also have constant. Let's see. Or I wonder if it would have been better for us to just have the x max be minus instead of having a separate variable for that. For now, we're not going to worry about that. Let's see. This last thing is the max acceleration and the minimum acceleration. So we're going to have acceleration min is equal to negative 0.001. Okay, there we go. There we go. Cool. All right. So now, if we hide that, this should have an initial velocity of 0.01, and then if we put it to the left, okay, how about we put it to the right? You know, it's actually, I don't know if that's working. Oh, that's because we're not returning, we're still returning angle acceleration. Let's return map x instead. There we go. Okay, so now we actually got it to speed up in the direction that we're looking at. That only took us about 30 minutes. I'm sorry for that. So I guess if we wanted to, we could extend this some more by making it so that the background square changes colors based off of the direction that it's currently heading. I think it would be actually really fun. It shouldn't be too hard for us to actually keep track of the mouse acceleration and change within this the color of something that we're drawing. So let's go ahead and do that real quick. I'm trying to figure out where is a good spot to put this. So mouse acceleration is in here. Let's see. I think the easiest way for us to handle this is by adding in a parameter to draw building. And within this parameter, we're going to provide the current color, and then the color is going to be defined up here, but adjusted within mouse acceleration. Now, this isn't really clean programming because we're allowing a global variable to be touched within a function, which is prone to errors, but this is a project that's not going to scale to be a very large project, so we're going to dismiss that. That's cool. Thank you. I think it's very cool too. I'm glad you're finding it cool. Okay, so let's store this. This is going to be, let's see, let's make it go from high values of red to low values of red. So we're going to have this be red. Redness um, okay, red angle. Okay, now some of the more astute in here may be a little bit upset with the way that I'm bouncing between the naming convention for these variables, considering the fact that this is like camel cased, where we have a lowercase first word, then uppercase next word, versus the underscores over here. Um, the way I like to write my variables is I like to snake case my variables like this, and I like to camel case my functions, but not everybody follows that convention. And well, right now I'm too lazy to rewrite these so that they follow that convention, so I'm just going to continue sticking with this. All right, red angle, we're just going to set this to be, what's the middle of 255? I guess we don't have to know, we can just let the math happen right there. Okay. So then we can pop in over here, and I think the 120 is actually a reasonable scale for the amounts that this can change, or I guess the min and max. So that means we can actually just take the distance x and adjust the red angle off of that. Distance x. Red angle, oh, I guess that's not a constant. That should be a variable. So let's keep our global variables together. So the red angle is equal to distance x. Actually, I would prefer it if we do something more like that. I don't... Okay, so const... I guess technically speaking, 255 is the max divided by 2. So then max red is equal to 255. Well, I think 255 is a reasonable enough of a magic number because we know that this is going into a color function. So we're going to let that be a thing. And then so this just means that we're taking half of the color angle, and then we're adding in the distance of x, which could be a positive or a negative value. And then what we can do is we can toss this into here, draw building, and then so now we can take in, well, this is going to be the, oops, the angle color. And then in here, since it's R, G, and B, we can adjust that. And then maybe we can just leave the other values at like 100 for now. And so it should start off as more turquoise, but then as we move more to the right, the background will change colors. There we go. Now we've got a reactive drawing. Oh my gosh, I accidentally just saved this entire page. Anyway, I'm glad you guys are finding this cool. Or you all are finding this cool. Okay, so once again, I'll be sharing this in the Discord. I think we've spent long enough on this exercise. There's plenty of more cooler exercises, so we're going to keep on scrolling down in the textbook until we can find the next one. So this is pretty cool. So as well, not that this other thing over here is not that cool. I think this is also cool. They can be cool for different reasons. So it looks like the next thing we're going to be doing is we're going to be adding directionality to our objects. If you missed the last GHW, we were basically doing orbital mechanics, a very elementary version of that, or I guess like gravitational mechanics, gravitational simulations. There we go. So this is an example from last chapter. We're just adding in some random rotations over here. So I think it would be relevant to try to understand what's going on over here. So I'm going to go ahead and pop this thing open. There were 3 function, or I guess like 3 files within this thing. The first file I like to look at is sketch.js because this is the one that contains the driving code, the primary logic that runs everything else. Ooh, I've got a great question in chat. How heavy is this P5 technology on the browser? That is a good question. I'm not much of a performance guru, but I will say that generally speaking, the most browsers that you run this on are going to be capable of running it, unless you just have like code that's pretty non-performance. Like it scales pretty, like the amount of calculations you can run on this is quite reasonable. Let's see, the draw function right over here runs once every frame, and P5 runs at 60 FPS by default, which is actually a pretty moderate amount of math that you can get away with on a computer, since it usually runs hundreds of thousands of calculations per second. And so as long as the kind of math that you're doing doesn't exceed that number, per frame, you should be able to run pretty smoothly. I've actually been able to run a lot of the P5 things that we run here on my phone, in my phone's browser, which like I guess phones are getting really, really good right now. But yeah, browsers are actually bottlenecked by the hardware, I guess the computer that you're running them on, as well. So I would say there's a lot of caveats or like nuances, considerations that you need to think about when we talk about performance. But for the most part, I would say the majority of P5 things that you run are going to run smoothly on the majority of browsers. I would demonstrate on my phone right now, but I don't know. I don't think there's an easy way to share that on stream. If one of y'all would like, I will actually go ahead and share this link so you can try it if you're on your phone right now, to just open that up. If not, you can try that out after stream. Actually, I'll go ahead and make a reply to my Discord announcements if you want to play around with this on your phone, and I will rename that hyperlink to the exercise accordingly afterwards. Okay, but for now, let's go ahead and check this out. Okay, let's actually, the attractor. I was hoping the attractor would have a, I guess like an argument in the constructor that would describe where it lives. If you don't know what a constructor is, no worries. I'll explain that in a moment. So what's going on over here is, let's go ahead and hide all these things. We've got movers and a single attractor. Okay, so there's 2 different kinds of objects we're keeping track of. The first thing we're going to do is we're going to, of course, create the thing that everything lives in. This is the universe that we have. And then we're going to populate our movers array with a whole bunch of objects with random, I guess like coordinate system, and then a random size. And then the next thing we're going to do is we're going to initialize a attractor. And the attractor looks like it's just going to spawn in the middle of the screen. So if I actually scaled this to be in the middle, yeah, there we go. Okay. So then if we pop into draw, we can see that we've got the display function over here. All this does is it just draws the thing on the screen, so we don't have to worry too much about understanding that. Okay, next thing that's going on is for every mover, we're going to let the force be equal to attractor.attract, which is just going to give the, I guess like these other objects a direction to move towards. And then we're going to apply the force. So then this is the thing that actually lets it move. or I guess it does the math to make it move. And then we've got update, which is the part where it actually, let's see. Oh, sorry. Okay, apply force gives it the new direction it's moving towards. Update is the thing that actually does the math to make it happen. And then show is the thing that actually draws it. I don't know why we moved from display to show as far as the naming convention goes. I don't think that's too important. So that's generally what's going on. And I'm cheating a little bit because I was in the previous stream, so I kind of already know what a lot of these functions do. You can look into how they're actually defined to verify the things that I've been saying. So for example, the show thing, we can expect that there's a lot of circles and lines. Something I wasn't expecting actually was to see this push and pop along with rect mode. I'm not sure exactly what's going on here with the push and the pop. I'm assuming that this is trying to make it so that the translation and rotation is per object. That is my assumption. But yeah, inside of updates, this is basically just the math to, I guess, like add the velocity on top of the current location of where the objects are, as well as the acceleration. So we can see here that, like, for example, the acceleration is being added into the velocity. Let's actually drag this out so we can see this a little bit more clearly. So acceleration is just equal to the previous acceleration divided by 10 to make it more like an approximation of gravity. And then we're adding in the acceleration on top of velocity. And then we're making sure that this doesn't go too high. So this is an alternative way of factoring in our like max speed. So yeah, that's what's going on over there. And then a tractor. Let's go ahead and hide these things. Okay, so yeah, display is just, oh, this actually lets us drag it, it looks like. No. Okay. I think that's an artifact, because basically this had, what's it called? In the previous example, we were allowed to, what's it called? Drag the object around. Okay, so yeah, the constructor, it just spawns where it is. Or I guess we actually set gravity is equal to 1. Okay. Yeah, not too important there, I don't think. And then attract, so this is just going to grab the mover thing, and it's going to tell it to add in whatever force it is to drag it towards the object. Okay, so that's a very rough overview of what's going on with the arbitrary angles, I guess. Okay, we've got a question. Could we do this thing with drawing 3 circles without using lib functions? When you say 3 circles, are you talking about 3 attractors or 3 movers? Attractors being the thing that everything else is moving around. And could you also clarify what you mean by lib functions? Okay, while I wait for you to clarify, I'm going to keep on moving on till we get to the next exercise, which we didn't have to go too far. Okay, so can we create a simulation of objects being shot out of a cannon? Each object should experience a sudden force when shot, as well as gravity, and then add rotation to model its spin as it's shot from the cannon. How realistic can we make it look? Okay, the first thing I thought about is in US middle school or elementary classes, we learn about like the American Revolution and how one of the big things, like the big war innovations, was the idea of a rifled barrel. And so that's what I'm being reminded of. The idea is that like adding rifling, which basically just makes it so that the bullet spins, actually stabilizes its flight a little bit. So that's that's what this is reminding me of. Okay. So I see some comments that I want to react to. I can see P5 being great for creating animated logos and navigations. Yes, I think P5 is a fantastic candidate for that. There are a whole bunch of other libraries that can do this as well. I personally like to use P5. Um, the only thing that you need to keep in mind is if you're planning on creating this as part of like interactive things, that you need to make sure that P5 lives in a canvas. And so it's very, very useful for things like textbooks. Um, where you can have, I guess, like little interactables throughout the page. Um, I don't know if it's the right tool for creating, I guess, like anything too fancy. I will say that within P5, there are actually a set of like HTML elements that you can create, mess around with. But on the topic of creating interactive logos, yeah, I would say it's a really cool way to kind of do that, especially if you have like a hero banner on your website. That is like the first thing that people see. We can actually take a look at like P5 right over here. So for example, this would be the hero banner. I guess sometimes it depends on um, the website that you're looking at. Usually the images are actually at the top, but P5 is built different. But yeah, I'm pretty sure like this logo right here is actually done within P5. I'm actually planning on updating my GitHub profile, I guess like banner with an animated GIF that I'm going to make within P5. That's something I'm planning on doing. Okay, so we've got the clarifications here. There's one static attractor and the others are being attracted to it. Yes, yes, that is exactly right. And if that is very exciting and interesting to you, I definitely do recommend going through the previous chapters within this series or within this textbook because they are fantastic. Take, uh, Vectors really does lead into forces. You don't need to understand everything within vectors. It would help a little bit. I would say forces actually does do a pretty good overview without having to worry too much about the details of vectors. Like it, there's a lot of things that I guess like make sense with how vectors work, which makes it easier to use forces, I would say. Okay, is P5 the most major library for the front end? I wouldn't say it's a particularly common one outside of the art community. I think there's a lot of other like really big animation libraries out there. Um, let's see if I could name any. Um, I know. Let's see. There's the design, like the motion graphic designer side of web development. And so I would definitely recommend checking out a few like things within like YouTube, for example. I think you might find some really cool other libraries. But P5 itself is not explicitly a major library for front-end development. It is specifically an animation library, and we can actually look at the mission statement for P5 right here. The idea is to make it an accessible tool for learning code and making art. So it's very much like a introduction to art and programming, or like programmatic art kind of thing. Lib functions like the math behind the whole attraction thingy from scratch. I guess I showed it though. Ah, yes, got it. Sorry it took me so long. Yeah, let's see, math behind. Yeah, I would say the math behind the example I showed right here is pretty much like none of this is really the only math that's handled by the math libraries within P5 is like the specific like vector math. So like how vector multiplication and vector addition and subtraction work. Those itself are actually abstracted. Um, so, and also like set mag. So I mean, it's not too hard to imagine how the implementation for the set mag function, like math or vector function, might work. But yeah, I would say the rest of the math is actually done here. Um, it's just that specific vector matrix like multiplications and functions are the only things that are abstracted away. Okay, 3JS is a major one. Yeah, I would say 3JS is probably the biggest one for 3D graphics. Um, I know, let's see, GSAP is another one for, I guess, like interactive animations as well. So if you want to do something with like actually interactable elements, or I guess HTML interactable elements, I think GSAP might be a better library than P5. Although P5 is definitely like an interactive thing, um, it focuses less on HTML interactions and more on canvas interactions. So things that you, I guess, like don't really manipulate things on the page for. Um, so yeah, I will say that a lot of these other libraries do cost money. This one is one that's, oh, it looks like it's free now, which is pretty cool. Perhaps another time I'll go through GSAP in future streams. But for now, I think, oh my gosh, P5 is just, it's a very accessible thing, and I think it's a very fun thing. The audience that I like to work with don't consider themselves programmers, and so I want to try to work with libraries that are less techy. Anyway, that's more of me outside of Major League Hacking. Let's keep going. We've got some more fun things to do. I don't remember what we were trying to do. All right, we're gonna make a cannon. Okay, so each object should experience a sudden force. Well, okay, so then the next thing is to make it spin. How realistic can we make it look? All right. Oh, forgive me for the yawn. First thing we're going to do is we're going to make a new screen. We're going to call this GHW exercise 3.3 Canon. Yeah, I feel like my naming convention for this thing changes every time. I'm going to say, like, I've got some of these things. Yeah, I've done GHW dash and then the chapter and then the exercise. I was actually pretty consistent for the forces chapter. Some of these are just like random things, and then others are just like random things for other projects I was playing around with. Anyway, yeah, my naming convention probably needs some work. I do wish that the P5 code, when it saves, it makes a commit and a new repo. That would be kind of nice. That way I could get my GitHub lawn, I think some people call it. You know, the GitHub, hang on, let me just show. The commit graph. Yeah, this thing. As you can see, I'm not as active as I would like to be. But yeah. Anyway, okay. Every Monday should start with art. I agree. Right now, I'm actually doing a art challenge. There's a, let's see, a server I'm in that's called the March Hotel, and basically, it is an accountability system to make sure you get some art in every day. Because I've been wanting to be more creative in my life, and so I think just like getting in an art project every day is a really good start to doing that. So as long as you get in 10 minutes of work and then you share what it is that you've been working on, it could be any visual format, you can get into it. It is also actually Monday today, yeah. It kind of is giving a little bit of Friday vibes, honestly. But yeah. I do encourage you all to try out to committing to some sort of creative habits. I think it makes you see life a little bit more fully. I think not to get too philosophical and sappy. But yeah. Okay. So let's actually start by drawing our cannon. Okay, so I guess a cannon. I'm gonna pop over to our whiteboard over here. Let's start by drawing a frame. That way everything can live inside this. And I think a cannon consists of two basic parts. We've got a wheel, which we can represent with a circle, and then we've got a rectangle, which is, I guess, like the actual cannon part. So let's go ahead and angle it like that. I think this is a pretty fair cannon. Maybe we can have another rectangle part for the part that sits kind of below it. Let's look at like cannons, actually. Oh my gosh, that's a pop band? Okay, let's look at this, for example, the nice 12-pound cannon, very, very historical. Or actually, you know what? If you all have an opinion about what cannons should look like, do let me know. I'm going to start with the 12-pound cannon, and we're going to see how we feel about that. I feel like the pirate ship cannons are also kind of fun. So I'm also going to grab this and put it here for reference. We can try both of them if we like, but for now, let's stick with the 12-pound cannon design, since that only requires, I guess, like 3 shapes instead of having to draw in wheels and this triangular thing. Okay, so then the next thing is we want to add in a cannonball. But we also want to be able to keep track of, I guess, what direction it's heading so that we can tell whether or not our barrel is rifled and if this thing rotates or not. Okay. I guess we're also going to want to make sure that this is a little bit more of a rectangular design, because we want our cannon to sit all the way down at the bottom over here, and then just kind of shoot. I also kind of want to draw in a ground. So let's go ahead and add in a draw ground function as well. We're going to make this return nothing for now, just so that we don't get the error. And then we're going to, let's see, for the ground, let's just start with something simple. We're going to start by drawing a rectangle. That's going to be the width of the screen. Or actually, it's going to be at the bottom of the screen. So let's make it bottom third, maybe. So we're going to do width divided by 3. Let's actually toss this into third of the screen. It's equal to width divided by 3. And then we're going to do third screen times 2. Okay, and then we're going to make it go the entire width. Sorry, this should be height, actually. A third of the screen. So then this should actually be, instead of that, that should be height. Sorry, width. Wait, no. Oh my gosh, I'm totally trolling right now. So the rectangle function takes in the x and the y. So then the first thing is actually well, we're going to be actually starting at 0 first off, and then we're going to be drawing to a third of the screen, and then so this is going to start down around here, and then we want the then it's going to be the width of the rectangle. So we want this to be the full width, and then it's going to be the height. So we're going to just do third screen. And so if we draw ground, we should get a rectangle. Yep, there we go. Let's actually get rid of the line around it, and let's color this thing in to be a nice kind of greenish field. Let's do a modest red amount, and then the next thing is green, so we want this to be higher, and then a modest blue amount. So now we've got a nice kind of green field. Maybe let's bring this down so we get a darker color. Okay, and while we're at it, let's also change our backgrounds to be a nicer blue color. So let's do basically the same values, but change it so that the blue value is higher. So RGB. Oh, that's kind of too bright. Let's actually bump this back up to 150 all around, and then we'll put this at around 200. 175 maybe. And then we'll bring this down to 100, 100. No, I don't really want it more purpley. I would like it. I want a nice, like, how do we get like a nice like sky blue color? Okay, so I think the nice thing is that we can actually toss in hex values. Okay, there we go. We're going to just take that. Sorry, I'm not going to figure that. Well, I guess I could try to convert this hex value into RGB values if we really wanted to. Because that's like, this is like 255 basically on the right. This is, let's see, C is closer to 200. And then this is, actually, you know what? Let's go ahead and do that. We know that last value blue is about that. This is about that, and this is about that. Okay, yeah, there we go. We've got a very basic Windows Vista background. So now let's actually start drawing the cannon. So we've got, let's have a X and Y over here. Draw cannon where, let's see, we want this to be at around a third of the screen. I wonder if we could extract this out. A third of the screen. And then we're going to toss this into the X and the Y. Third of the screen. That's on the Y. And then on the X, we actually want to make this maybe over here-ish. So let's, that's like a sixth of the screen. Let's do a third of the screen divided by 2 to get our sixth. Why is that throwing hands? Third screen is used before declaration. All right. So what we need to do then is basically we need to declare it in the global scope first, and then define that within setup. And then that should be less of a problem. Cool. Okay, let's actually just start by drawing a circle here at x and y. And we'll give it a radius of about 25 for now. We actually need to make it so that this is times 2. Or actually not that. We need to make it so that the y is times 2. Okay. Well, thank you for the bye message. I really appreciate having had you on stream. Good luck with learning C, and have a good night. Thank you so much for tuning in. If you want to see what we do at the end of the stream, you can always check the recording on YouTube, or you can check the Discord announcements for the links on whatever it is that we've built. But yeah, thank you for tuning in. Okay, so we will still need to make this a little bit bigger. Let's go ahead and make this twice as big. Let's make this a different color as well. Let's actually, instead of having a different color, we're going to make this more of an outline. That way we can draw it like it's a wheel. Thank you, Quackers and Cheese. Always the helpful. You're like the Pocket MLH like links person. Appreciate that. Okay. Let's see. Now we want to have a stroke color, and we want this to be kind of a brown. So a brown color is high on red and high on green, I believe. So let's give this like a 255, 200, 150 color. That's a very human colored skin tone, very pale skin tone. Let's make this 250 and then bump this up to 175. Let's also make it so that this stroke weight is a little bit bigger. Let's start with 4 pixels. Okay, that's very unnerving. I do not like that coloration. Let's make this a little bit darker. Oh god. Okay, I'm just gonna look up a brown color. Let's do cedar. I think cedar is pretty nice. I think I'm going to... You know what? I feel like I need some practice reading hex values. The more letters that's in it, the higher the value is. So 4B is kind of a moderately high value. 3A is right around the same amount. And then the last value is 26 in hex code, which would translates to about that. Okay, I'm bad at my hex math, so we're just going to take that as is. 4B, 3A, 26. That's kind of too dark. That's not the same darkness that we have there. We need more Ryan streams. You know, the really funny thing is that there's a few other Ryans within Major League Hacking, so technically speaking, there are already a bunch of Ryan streams, but I appreciate the love. If you need more specifically of me, I will continue to try to be here as much as I can. 3B, 3A, 26. Let's see. I want to brighten this up. Let's see if we could bring this up a touch. Okay, there we go. So I've just raised the R and the G value by about like 30-ish points each. We need more Ryan #2 streams. Thank you. I appreciate you getting the number out. You actually got the right number too. I'm the second official Ryan. I don't know how official it is. But yeah, I appreciate that. I appreciate you. Okay, let's make that a nice round 8. Let's actually make this go a little bit further down, I think. I don't like how perfect it is. Okay, there we go. Yeah, there's like this rule within the art community, very unofficial rule for avoiding these like uncanny kind of things. And the rule is if you are, like, let's say you're drawing, what's a good example? Let's say you're drawing like a couple of buildings, right? It looks really weird if the angles, I guess, like perfectly line up with something else. Maybe for buildings it makes more sense. So like, I don't know what this rule is called. Okay, actually, instead of like drawing a separate thing, let's actually just use this cannon for example. I guess that looks okay. Well, okay, so the rule I'm trying to describe is a rule that says that a lot of objects don't really like perfectly line up like that. In real life, they generally have like, I guess, like these lines. They don't. I think they're called like, it's like the tangent line rule in art. Yeah, here we go. The idea is to avoid having objects touch at like a single point. It just looks kind of strange, and so the idea is to have, I guess, like greater overlap. And so that's what it is that I'm trying to avoid right now with this. Now that I think about it, I think that this brown doesn't really contrast super well with this green, so we may adjust the green a little bit. Let's go ahead and do that. This is the ground. I give up. We're gonna do grass green hex code. 48 6F38. Oh my god, that's terrible. Okay. Let's try that. Okay, I think this is a serviceable color. Okay, so now we've got the wheel. Now I want to draw the barrel. So now let's just start by drawing a rectangle. We're gonna give this, let's see, half the radius. Yeah, let's give it half the radius. So we're gonna put it at 25. And then the location should just be at X and Y for now. That way we can get our bearings straight. Right. We actually also want a width. Let's just make this twice as long. Put it in, let's swap that around. So the width is like that. Let's make this a little bit wider, actually. Let's make it 65. Okay. And then let's subtract this by 25. Let's subtract the height by 25. Okay. Let's make this a little bit more readable. Okay. Let's see. So we actually do need a little bit of an X offset if we want to try to copy this. So the x offset looks like it's about maybe a full third of the circle. So let's just do let radius equal to 50. That way I can actually refer to this more with proportions. Okay, and then we're going to set this off by the radius divided by 3. And then this is, let's put this all on different lines. Okay, so let's see, x radius, y is honestly pretty decent, as is. Okay, so then the 65 is kind of like an arbitrary size, so we can leave that as a magic number. And the 25 is specifically to be half the radius. Oh, why did the y get all screwy? Did I have something here before? Okay, and let's rotate this. And the angle for this, let's just do like 100 degrees. Oh my gosh. Okay. I think I know what happened. This angle is about 100 degrees out from here. It's on this arc right over here. So we can't actually work like that until we adjust the translation. I wonder if, let's see. I don't remember how to undo the translation and rotation thing. Yeah, I think the cannon was a little too strong. We haven't even gotten to the launching part yet. This is the ultimate literacy test of like, did we actually understand what's going on with the translations and stuff? Okay, so let me get my head straight. Let's move the well, okay. I'm trying to figure out whether or not we should take this x and y and use this as like a translation thing, or if we should just draw them like in the spot. Let's actually just try and see what happens. I don't remember what arguments translate takes. So let's pop over to the references. Translate. The default is 0, 0. It is, yeah, it's just a x and y value. So we can just give it an x and a y, which means we should now set this to be 0 and 0, because that's the origin. Oh, that's kind of cursed, not having the x and the y there anymore. I'm gonna leave a 0 there because it just feels weird without it. Okay, there we go. And let's add in the rotate, and we're gonna hope that this works. Okay, cool. That actually worked. I wasn't actually expecting that to work first try. That makes me really happy. Okay, so let's change this so that's the barrel stroke. Let's go ahead and copy this actually for now. Actually, no, we don't want a stroke. We're going to say no stroke. And then we're going to create a fill of that value. And instead of this chartreuse looking thing, we're going to bring this all the way over here. And now we've got a gray. There we go. I guess it makes more sense for us to draw the barrel first and then the wheel afterwards. So let's move this up over here. And then that means we will need to move the radius. So let's go ahead and move this over here. We can change this from radius to be size, since I think that is more general purpose. Okay, and then let's see. We also want to have that rotation right there. Okay, so now that's behind. And let's see, I do wish the cannon had like rounded edges at the end instead of those sharp corners. But I think that's going to be a lot of work if we try to fix that. Whoops. Okay, so let's draw one more rectangle for the lower half of the, it's not the barrel, it's the, I don't know what the rear part of the cannon. Okay, so it's basically all of the same things, except we want to drop this down maybe another half. So instead of dividing the size by 2, we're just going to take the full size as is. And then as far as the x value goes, we want to make it more to the left. So that means I'm going to wrap this in parentheses and multiply this by 2, and we're going to see what happens. Okay. That didn't behave the way I was expecting it to. I think maybe, let's see. Why did that change? Ah, okay, so this was size divided by 2, and we're subtracting, which means if we add, there we go. Well, that wasn't quite what we wanted, actually. So then maybe we actually need to divide this by a smaller amount. There we go. Divide by 4. I also want to make this a little bit smaller. And let's see. So then the x size is this first one. Okay, this is the reason why we extract all of these out into more variables. Okay, this is the x dimension of the rectangle. So the x dimension of the rectangle is 65, which I think is fine. What we want to do is we want to make this even smaller. There we go. And then maybe we make this a third. No, I think fourth was closer. 6, 8. All right, cool, I guess. There we go. All right, cool. That's close to what we want, I think. Let's make this a little bit bigger. Let's make this full 75. All right, cool. So now we've got our cannon. That took way too long to get our cannon. And I realized if we want to add like our mouse as like an aiming part of the cannon, then that we don't actually need the rear part of the cannon. You know what? I'm just gonna get rid of that. That way I'm not tempted to do anything with it. Yeah, and I think I got a little distracted, but now I'm trying to figure out how to fix this. Okay, so the rotation angle. I know this is going to be a value that we want to adjust outside of this function. So we're going to go ahead and hide all this. And in here, we're going to give it an angle of 100 for now. Let's see. I'm going to add in a thing that just says x offset, which is equal to 25. That way I don't get confused as to why that 25 is there. Okay, cool. Cool. All right, so now let's actually get the cannonball function. And then we will once a rotation thing. I don't know if we're going to get there. We only have like 9 minutes left. Oh, hi, y'all. Thanks for joining. um, we are getting close to wrapping this up. Okay, so 9 minutes. Let's see how far we can get. Cannonball. We need to spawn a ball. So let's just start by doing the draw. That way we can see what we're looking at. And let's just give this a size of 25 for now. Okay, let's also make this actually easier to see by giving it a fill color of, let's just give it like just a dark black. Like, I generally don't like drawing absolute blacks. The reason why nothing's being drawn is because we didn't actually call the function. Boo, 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 boo. Cannonball. And we can give it all of these values right over here. Except for the angle. Well, the angle doesn't really matter right now. Where is it? I don't know where this cannonball is being drawn. Since this cannonball is the last thing to be drawn, it should actually be at the very top. Let's make this bigger until we can actually see it. Oh my gosh, it's off the screen. All right. It's also got a stroke color, so let's remove that. Why is it off of the screen? Oh, it's because the origin point has been changed now. Okay, so actually before we leave this then, we should actually retranslate the origin point back to be 0. So let's see if this resets the translation point. There we go. Okay. So now we've reset the translation points, and that means our cannonball is spawning right where it should be. Cool. I think our cannon, we actually need to make it so that the barrel isn't on the top third. Let's actually just make it sit right in the middle. Oh my gosh. Divide by 3. Divide by 2. Divide by 3. What is size divide by 3? Is that in the middle? I can't actually tell. I don't think it is. That should be like radius, right? Well, no, the radius is right there. If I chop that off, then the size... This is so goofy because the rectangles have a different point of origin than the circles. That's why the math gets kind of goofy. I think 3 is close enough. Oh my gosh, I keep getting distracted by the aesthetics. I don't think I'm going to be able to finish this in time. Okay. If I do finish this, and no promises that I will, in the near future, I will add it as a reply to the Discord. To the Discord announcement. Oh my gosh. Sorry, it's morning over here where I'm from. Okay, so this is the X direction, the Y direction. I'm really getting fixated on this. I actually want to make this go back a little bit and make this a little bit bigger. The X direction is fine. I want a chunky cannon. I think that's too chunky. times 3. I can't help it. I just really want to work on the aesthetics of this project. Okay, that's not amazing. But it'll work. All right, so we've got our cannonball. I want to make it so that the angle chases wherever the mouse is. So let's go ahead and do that. So draw a cannon. Instead of 100, we're just going to have this track the mouse. Oh no. What I wanted to do is I wanted to have like a it would require like a polar coordinate system in order for us to actually track that. So instead of doing that, we're just going to make it track the mouse X. Actually, there's a way to get it so that P5, not follow mouse, look at mouse. I think there's a way to do that. There we go. I'm just going to copy that. That's not quite working either. What's going on? Okay. You know what? I think this is a good wrap for today. If you would like to actually fulfill this cannon's dreams of existing and actually being able to track where the mouse is looking, I'm going to give you the code that we built today on stream. I think this is a good wrapping up point and a good opportunity to invite you all to the next GHW stream, which I believe is probably the Today in Global Hack Week for day 4. 11 a.m. in my time. Yeah. Okay. So go over there. Send some love. Where is it? Where's the register? Oh, I thought there was an event link. Okay. I am assuming that it is the lovely Paul who's going to be running that because he's right here on stream. So yeah, go say hi to Paul. Tell them Ryan number 2 sent you. And I'll see you all again very, very soon. Take care, everybody. Thank you for tuning in.